Okay, what operations do I need? We need several things. I'm starting to think that maybe the things that do not concern themselves with rows and columns, which is the whole point of this exercise, aka this, for example, it doesn't care whatsoever what the bits mean. It just every bloody bit of data is being ANDed with the other bits. I think I should move this to vector, because I just don't want to have to type the template all the time. In the case that, you know, it's not even using calls rows or bits. Well, it's using n, but well, I could use size of data here. That's the same thing, of course, but well, looks different. Still work on data though, so then data must be protected. Now I'm going to move this to that's called over at the end, yeah. That looks a lot better, I think, and still I want my O-stream thing to be at the bottom. Or sprint on. I could just do this. This class defines print on. Then we do that. And I think that's all I need. Well, any include, of course. Oops. That's not in any namespace anyway, so maybe I should just put that in vector template, which is kind of, well, also having it. Sprint on utils as print on. Stream says a print on, so we don't need the operator anymore, which I don't have here. But we definitely don't need it here then. Let's see if that works. That works. Yeah, this includes bool vector, which includes vectors, includes and so on and so on. So even this one can be removed. It just, I'll pick up print on anyway now. stack smashing detected. Surprising. How else is that possible? Was that just because I remove the O stream here? Confused. Let's add it back. Standard O stream reference. Nope, that was not it. Must be a recent change though. Still stash making. The only other change I made before this started happening was making data public and moving it to vector. That cannot be it. Can it possibly be the reason? Oh, wait a minute. No, not true. Size of arrays. Oh, it's not. Yep, I'm a complete idiot, really. Oh, this is bad. Size of data. What a complete idiot. I meant that. That was the reason. Now it works again. Jesus Christ. Right, add the other stuff back. Right. Solver. Okay. I want to add a header above it, one that is completely automatic as well. Like as this is row 0, so maybe just add a row -1 and have that print a title. Hello Sam, how is you? So far I'm printing only one thing, that is mines, this vector here. So what if I just pass a name to it, like mines? And then we have that printed above the first row. So the bool vector now takes a character const pointer or maybe a string. Let's just use a string. Call it name, pass that to vector. So we printing just prints vector. The default constructor now becomes standard string name. Yep. But we have to pass all this shit. I think you do pass a name on to that. Yeah, name always must be passed, so here we also need a name. We put the name first. And then pass the name on to vector template. and then the print on. You just have to print starting from row -1. That would be the title. And then print row on. Just tags if row equals -1. Then we write the name. And then we return. But I must make this as wide as this thing is. How wide is this thing? One less than 2 times the number of columns, right? As if I know that. I don't know that. I don't know that kind of thing. Start a new chat. Is that a TPP file? I never heard of TPP. Well, we can only hope that it worked. It looks kind of like it could work theoretically. And they said the width had to be 2 times the number of columns. Wait a minute, -1. Which comes from IO manip. Didn't include that here. Very good. Let's see if that compiles. Oh, it's not the direct base class of vector. Totally direct base class. I think it is just confused probably by... No, I don't know. What the hell's going on here? I'm just putting everything at the bottom of the header, yeah. Okay, can you tell me what is this about? It tells me that is not a direct base class of vector. Well, excuse me, what is this? Am I being completely crazy again? What the hell is that? Seven, 8, 4. Oh, wait a minute. Yeah, no. It uses the calls from the base class. That's a bit too confusing, isn't it? Let's give these things capitals because I'm getting tired of it. Now bit doesn't really change, but still. And the calls here is this is really the calls from the base class, so I can leave that. Error. Expected identifier before string constant. What kind of errors is this? Expected, I mean, what? That is an identifier. Bool vector is included. Then we get a name, and then we get a constructor. And it doesn't work? Okay, it doesn't work. This works, however, so why? Can't do anything these days. Penalty not. Okay, whatever. I'll add it to the constructor. No, we don't have a default constructor anymore. Temporary. Well, that was the last one. I don't want to add titles to every vector that I'm going to make. So let's remove this one again and then make a default constructor anyway, which then just doesn't have a title. Or no, maybe I should do it like that. Now it prints mines above it. It's nice, I think. I want an empty line in front of it, however. So let's begin with that, and then maybe a colon after it. VI, where's my printer? Let's print a name and then print a colon. Because the colon comes after that, we have to subtract 2. I would like to have a little indentation, really. So maybe remove the whole separator idea and just add a space here. That's an idea. Don't have a sep anymore, of course. VI. I removed it. Oh, and I did not remove it. I meant space and then that. Which makes the width 1 larger again. So now we have to subtract 1 again. And then the colon comes there. Nah, I want the colon directly there. So, oopsies, that's not good. Now we have to this whole stand on the left thing doesn't really work anymore now. Let's just print name and then print that and then print a number of spaces. So standard string spaces with some length or calls minus name length. Let's see if this comes close. It compiles, it printed spaces, I guess, so and oh, there it is. I didn't see an exclamation mark, so I thought that's weird, but it is there. Really? How did that happen? Standard string. Nobody knows why. Constructor. Yeah, it's the other way around. It's count, comma, char. I'll always have that the other way around. First the count and the char. So, fixed. Now we have a title. Pew. And now I'm finally going to work on vector. Vector itself now has an operator and is I also need an operator OR. That is an easy one. Done. Okay, what else do we need? I need a subtraction. I need a normal AND. We need an inversion. Inversion is probably... I want to do stuff like this. This returns just a vector, and then we want to do that. But this inverts known, which is also a vector, and then does an AND. So what it really does, it clears everything. Yeah, it clears everything that is not already known. No, it clears everything that is known. Yeah. So maybe I should, instead of adding an inverse and an AND, because I always use them as a pair, might as well remove both and then say clear known. Yeah. Yeah, okay. So you just copy this again. It's probably going to be the same, mostly the same. And then we do, it's not called clear. We run over everything. And I want to do AND with the inverse of that. It's kind of a combination of that one, but then with an inverse thingy, instead of separating them. Hello, Sam. I'm afraid I don't even understand the question. Do header files strictly have the scope of pre-processing in mind? What is the scope of pre-processing? A header is just to define the API, the interface. But you don't want it to generate code, except one, the linker can deal with it, and the linker can only deal with templates and with inline functions. If you define a function, a member function inside a class, it's per definition inline. So the result of this is when I have multiple translation units, aka .cpp files, and they all include this header, then they will all generate a function. So then you have multiple translation units with the same declaration, but the linker resolves it. because it's marked as inline, and then it says, well, okay, let's allow that. But normally, you know, there's stuff like this, just the interface. We have a constructor with these parameters, so it doesn't actually generate code. Nothing to do with preprocessing here. Okay, I have a clear. What else do I need? Subtraction. I want to be able to do stuff like this. Vector minus another vector. Friend vector operator minus. Yeah, I can also define it without a friend, I suppose. Vector const reference order. Let's call this order. Let's call this right hand side. So then this object is the left hand side, and we're going to return a result here. Yeah, I'm just going to make a copy, I think, of the current thing, and then implement it in terms of right hand side. I think we already have a copy constructor that is not defined. The compiler would generate one called copy constructor of that thing, which is just copying the array. By default, that should work. I have to still then define this thing. That is nonsensical. It is a void, of course. Or, yeah, well, I could return a reference. It's a normal operator, assignment operator. So I could return this here. And then for the rest, again, that loop. Now note that the size of data is an array. That's hardly a function. It's just a const expression returning the second template parameter of the array. So this is a constant, like a literal constant. And in our case, it's going to be 1. So the compiler is going to look at this, says, okay, for I is 0, I less than 1 plus I. Well, that's not a loop. It's just 0. So then it knows it just get one line, no loop. Data 0 and or and data 0 is just an uint 64 type. So it's just 64-bit int. So it's going to do that. That's like one clock pulse. So maybe 2 assembly instructions. You have to invert something and then end it. But this whole function is going to be like, yeah, one clock pulse, one clock cycle. Even though it looks like that. I didn't fix it yet. We have to subtract. But this here does make a copy. We make a copy in order to be able to change it, and then we return that. But since our whole vector is just a single single integer of 64 bits. It's making copies. Yeah, well, it's a built-in type basically. Okay, we have subtraction now and clear, and I need more stuff. I need OR. Okay, let's implement OR in terms of that one in the same way as we did this one, right? Just copy that, put that here. To make it an OR. Might as well add an AND as well, even though I might not use it because I don't know if I need it, but that would be binary operator and bitwise-AND. And then I actually need that also. I need it. Right, then I have everything except an equals and an explode. We need a function that, I mean, I don't think I need a exclusive OR. It's like, no. I do need a multiply, however. Yeah, I need multiply. Or maybe let's... I don't know where to add that yet. Though it works on the vector, let's just add it here. Okay, so I want an operator. Turn to this operator. Multiply with an integer. Now there's only one multiply that I need. So I don't even have to pass anything. I'll probably name it differently. Let's call it, it's more like the clear. Why the clear is, oh well, why not? So I had a clear and now we have something else, and then I call that to mask. It's more function of the Boolean vector though. So let's not add it here, let's add it in the Boolean vector. So we have a Boolean vector, and if you're on a Boolean vector called toMask, then it returns a vector where every bit is set in the returned vector if the Boolean vector was true. If you get what I mean. And the fastest way to do that is not by running over all elements, checking if it's true, and if it is true, filling in the mask. No. I just do a single multiplication. Well, single because our array has a size 1, but for the rest, it could be 3. I don't know where I am, there. So we run over everything, and then we just multiply everything with something. That's it. Where something, well, that depends on the size of the bits. Yeah, I need the integer that I need here is 1 less than something like something minus 1, or this is then bits, no, 1. Yeah, I'll shift left bits. So again, turning bits into a mask. Oh, I already had that. That's a const expression thing. How did I call that? Value mask. Or not, because it doesn't highlight. Value mask. It is called value mask. Yeah, that obviously turns every element that is a 1 into all ones. So that should work. You can even test it, I guess. If it compiles. It would be nice if it compiled. We don't have an arrow. We have a right-hand side. So let's say we test it as follows. I make a boolean bool vector. I don't have that filled yet. I need to fill with something random. And that is the grid. So this is the grid, but it just prints mines, and this is actually the mines that we print here. Now I can do the following trick. I can do vector no masks. That then should not compile, or does it? Yeah, it does. Not sure. Still going to print mines now. That's not the idea. Code them or that. Okay, so all the zeros stayed zeros, but this one has become 15. Yeah, we can't print that. No. At least then the assertion fails. But it's true. I want to be able to print it, so I'm just going to print hexadecimal values. So this assertion here should not fail. Till demand that it is equal less than 16, and then we do v is less than 10. We print that, and all else we print a plus something, where something is v minus 10, right? is v equals 10 and this is 0 to print a, and this v gets larger and pick the next one. $70? No. Well, 7, wait a minute, what is this? Hexadecimal? No, it's really printing 70. That was not the idea, of course. This becomes an int. Let's make it a char. Right. So that worked. Every one that we have here is just turned into the full mask, an F, for ones. Yep, so that works. And then what is next? Okay, I need an equals. Looks like a free function. It's a lot like what we just added. I need a vector. No, this must return a bool vector, which is that problematic. Equals int value const. This is more difficult. This should return a bool vector with the true value for every element that equals value. First I want to know if bool value is even known here. I don't think it's known, so cannot, definitely not known here. Cannot return a bool vector. Can you return a bool vector that is 4 declared? That works, okay. Right, so how to do that? Well, since we want to do everything in parallel, I want to not pass a value, because then we have to expand value into a vector of all values, which is a lot of work. I could turn it into a template and then hope that we can do it with this one. We should be able to make it a const expression function. Or I can just be lazy and demand that we pass a value as a vector. And now it just returns if the current vector element x equals the value that we pass here, then we return true. Okay, so step 1, we do an exclusive OR. I do need an exclusive OR. Okay, so we do the current vector. Let's make a bool vector as the result. And I want to copy. That's pretty nasty, isn't it? I don't think a bool vector adds anything. It's just it's equal to a vector. I'm going to declare a vector, I think. And now we return that. The purpose of a bool vector is actually just that it, in the hope that it's less error prone. I could just work with vector everywhere. But the point of the bool vector is that it is supposedly only containing 0 or 1 as values. Yeah, now we run into a problem because the compiler is going to refuse using copy elation unless I work with the bool vector. So I can return a result here, but then I can't think of a cast such that I'm sure that it's going to use copy elation. Copy elation meaning we do something, we return by value. Let's first make it work. So this is on the stack and we return this by value. But if you call this function from somewhere, then that somewhere also has a stack. And what it's going to do is it's going to allocate this bool vector on the stack of the caller. Yeah, so the moment we enter here, the result is already there. It's just on the stack. So we don't create it, it just exists already. And then we work with the result. And then the moment we return the result, we don't have to return anything because it's already on the stack of the caller. So there is no copy. This is not a copy. So the caller is like the one responsible for the lifetime of this bool vector. That has to construct it, of course. But then we can return it without having a copy. And that's automatic. So super fast, but that will probably only work when this type is actually the same as that type. However, I have to temporarily work with vectors. Now my bool vector okay, let's do something really dirty. I can do vector pointer is result, so the pointer to result. So now we have base class pointer. Bool vector is publicly derived from vector, so we can do this. And then I can construct it with a placement new. And then we call the constructor here. And I want to construct it from, just copy constructor home value. Because a type value there, but I meant vector, sorry. So this result is now on the stack of the caller. So we don't, this is not being done. And then we call the constructor of vector, passing the this pointer that is equal to, well, actually the pointer to the base class of that, which is just the this pointer of that one as well. So what we really do here is construct a vector, using a vector constructor to construct the base class of this Boolean vector. And then we can return it because the actual value of the type of the bool vector is just this one. So now it will work. Feels a bit dirty though, but yeah, well. Okay, what did I want? Yeah, I just copy it, right? Copy it, and then we do an... Sorry, I did not want to do that. I wanted to copy the current object. On the other hand, I'll just copy the array. This probably is safer, but it's also going to copy the string, which I don't want to. Maybe we should just copy the array. Yeah, it's way more logical, right? Forget about that. Result.data is data. That's what I really want. Do we have access to data? No, we don't have access to data because it's way up. And data is, oh, data is protected. Well, in that case, we do have access to it. This might just compile. Let's see if that works. Nope. But that's for a different reason, it seems. No declaration matches. I didn't add an equals. Did I not add an equals? Oh no, I changed the value thing, yeah. Equals, so now it's like that, passing a vector instead of an int. Nu met je functie call to default constructor. Yeah, that's definitely problematic. So I want to have that added back, I think. I don't want to call the default constructor of a string either. It feels slow. It's kind of annoying. I want to be able to make a nameless Boolean vector because, yeah. Also, vector already has that. Vector itself. But that initializes the string. You know, I'm not happy anymore with string because I just, well, yeah, I'm such a speed freak, right? I want this whole thing to be a single unsigned int64 type, and now I added the string to it. Talking about slow. That will work if I'm not creating and destructing a lot of variables, but I probably will. So I think that at the very least, I'm going to go back to not a string, but just a pointer. Okay, click on this pointer, name. Slightly cheaper. Yeah, but I don't have a length anymore. Okay, this is just printing. I don't care about how slow that is. Seriously? No, let's standard string len, is it? String len name. C code. Talk about C code. That would be include C string. I'm missing a lot of stuff here. Oh, here's another one. Character const pointer name. Now, what was the last thing that I changed? We are working on equals, right? Equals. Okay, so let's return a Boolean vector where elements therefore are only 0 or 1. And they are only 1 if the content of the current vector equals that one. How to do that? So I copy the data of the current one in here, and now we do result exclusive OR with value. I don't have an exclusive OR yet, so let's add an exclusive OR. Okay, after the exclusive OR, it's clear that only when the value was the same, it's now 0. So now I want to convert all the values that are 0 into 1 and all values that are non-zero to 0. and that in parallel. Well, I think we first have to do it the other way around. How do you do that? So what I want is to have a binary value. The binary value, a number of zeros must turn into a 1. And everything else must turn into 0, 0, 0. Now, of course, we do that by assuming that we have a function. So I'm going to run over all elements. Index, no, that's not it. I want to run over all I just do data size again. Result.data size. No. Data I. I'm gonna use a copy. Don't ask why. Right, so if we do an exclusive OR of the current object with value, then all elements that are 0 were equal to value. Therefore, if I call equals 0 on every array element, and then that does it magically what I want. Yeah, then we're done, kind of. But now I have to write equals 0. Well, this function needs to know the bits, yeah, of course. I'm gonna pass it as a constant. You never know what optimization happens. Now, if bits was very large, then we would definitely want to do some kind of logarithmic thing. But I'm wondering if bits is small, and it pretty much is, right? Although it could be 4, maybe I'm gonna make it 8. 8 is already pretty big. So I think that what I want is that every bit what we want is that every bit ends up on the least significant bit of each element. Let's say we have not 64, but we have only. Okay, I'll just type something like. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Well, should be enough. Maybe 2 more for good measure. God, these are 4 times 8, 32. So the actual thing is twice as much bits. And if this is the input, then the output must look like this. 0, 0, 0, 1. Yep, meaning that if there is any one set in these 4, then all 4 must become 0. And only if all of them are zero, then this must become 1. That's actually a super fast way to do that. Oh, there is a super fast way to do that. First we take the inverse, so then we get 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 1, 0, 1. 0, 0, 1, 1. Yep, then now we just have the inverse. And then add that. Now, if we add that, we get 0, 0, 1, 1, 1, 0, sorry, 1, 1, 0, 0. That's not working. I need a 0 in between everything. I was thinking if I add a 1 to this, then we get a carry. And none of the others gives a carry. How can I detect that I got a carry? Must be detectable somehow. Still going to try this. 1, 1, 0, 1. Ta-da. And now this is going to give me all zeros, but we have a carry, which adds here a 1 here. So this now becomes 1, 0. And then here we have 0, 0, 1. Yep, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0. Song. You can hear the music on my headphones. Yes, I'm almost leaning into the microphone, so maybe. The song that I'm listening to is that thing. This is what I'm listening to, but I don't think you can hear it. Okay, what do we do with this? So if this was a 0, it became a 1. If this was a 1, it became a 0. This is a 1, so it became a 0. This is a 0, became a 1. They are just inverted, right? All of them are inverted. Except, I hope. Except this one. Nope, also inverted. Shit. But that's because it carried over to that one. So maybe I can make this whole thing non-zero. While everything else is 0. Not going to work. It's probably an what is that assembly instructions called? MMXX or something like that? MMX? I don't know. I think there's a instruction that explodes stuff like that. So you can just insert zeros everywhere. So I could change an UN64 to 128 bits, where all of these things get separated by 4 zeros in one instruction. And then I can add to that, and then we can detect overflow. So then you just shift it and then collapse it back. That takes way too much time to look up, so I'm just going to ask ChatGPT. Who knows? Okay. What are those instructions called that work on Intel CPUs, for example? And convert 64-bit integer to 128-bit integer by inserting n bits every n bits, where n is 2, 4, 8, 16. Question mark. Is there an 4, 2? Yeah, but it's not going to speed up anything then. Let's just forget about this instruction set. was a bit far-fetched anyway. I think there's another trick where you just, I mean, using a carry is, yeah, then, you know, interfere between the elements. That's really bad. So let's not do that. Did I not have a solution here? Oh, the bottom one. Yeah. That's what we desire. What I could do is what you can do is how does it work? We have to begin with that, or it makes me think about transposing a matrix. Shift and XOR. I already know it's, yeah. Can you write no, let's do it in little steps, otherwise it gets confused. There is an algorithm that generates masks, and I am always talking about 64. No. In a loop such that they have the values Mm-hmm. 1 byte, 2 byte, 3 byte, 4 byte. Okay. No, that's not what I wanted, I think. 1, 2, 3, 4. 1, 2, 3, 4. Comma 0x 0 0 ff 0 0 ff 0 0 ff. Yeah. And finally, 1, 2, 3, 4. 1, 2, 3, 4. Respectively. This works by starting with the first mask and then shifting it well, that's halfway, right? So that is how many? 32 bits? 8 times 4, yeah. Shifting it 32 bits left and XORing it with itself. Previous mask. Then shifting 16 bits, then 8, and so on. I have template parameter int called bits. Can you write a const expression? How do you call that? Meta programming, right? Template function. That will return an uint64 type such that the number of consecutive, how the hell do you write consecutive? Got it. Number of contiguous set bits are equal to bits divided by 2. It's not finally, we even go further. Yeah. 3. That's correct. You can say a lot about ChatGPT, but it is fast. It always immediately has an answer. Well, and then it goes slow, but... It actually worked. Well, it's half. It worked for half. Auto generate mask for... Yeah, it starts with those masks as it's too small. Does this work? That's better. Yeah, it's kind of impressive, I think. Okay, let's try one. Yeah, that's indeed not possible. 2 is small, so 5 looks perfectly. Yep, cool. What about 8? I'm convinced. I'm really convinced there. Yeah, that works like a charm. Okay, one more. 32. I think even 64 should work now I think about it. So let's just remove the static assert. No. Okay. Or bits equals 64. Nope, that didn't work. Do we now have to start with 64 here or what? Oh wait, actually it did work. No, it was already correct. So I do need, why do I not have to start with? Oh, stupid. Of course it's 32. Well, this works. Yeah, just missing zeros in front of it, but they are there. Okay, let's copy this. Um, So the first mask that we get out of this is one that starts with the half zeros and then the rest ones. So that would be this. I'm so not convinced that it's going to make this evolve. And then you're 100% sure that the compiler does it during compile time. So now this just returns a constant. We initialize m with that constant, right? This constant. So. Likewise, we need a mask. Well, m inverse, which of course is that. Nah. So now I want to copy the upper half on top of the bottom half. So we have to take this one rather than that one. Yeah, this was a constant anyway. Maybe we should return the inverse of that. We could shift the other way, but it's const expression anyway, const value. So now we have this, and then we do an AND with the value. So we get upper bits is value and mask. So that would be 1100 0100 000 000 1100 1100. Yeah, just the first two of the value, and then the 0 for the last two. And then I can do change value to value now, or with U shift left 2. But the 2 is the half of bits. I'm gonna need more of that in the loop, so let's shift it S, and I initialize S with bits divided by 2. So this now becomes, well, then we shifted this value, that's U, two spaces that way, and then we do an OR with value. So that becomes 1 1 1 1. Those two on top of that. 0 1 0 1 0 0 1 1 0 0 0 0 1 1 1 1 0 1 0 1 0 0 1 0 and 1 1 1 1. This is now the new value. And now all the information that we want are in the last 2 bits. So now I want to shift this bit on top of that bit. But we might need more work, so what I really want is to change my mask like that-ish. Wait a minute, I had M as this. I want to now produce another mask, so M is something else. And that then is equal to, well, this thing, but then halved. So that becomes 0 1. And we do that by shifting the old M. So I do an exclusive OR with the old M shifted S as well, right? Bits. No, bits is 4 here. No, I need to shift it 1 now. So I need to halve S. Do that anyway. Let's say S divide S by 2. So that's 1 shift 1, and then we do that. Yeah. Is that correct? Shifted this S, so it was 2. Now I want the next one. Yeah, it's just half of that. That should give us that one. And then I want to do the same thing again as we did here, I guess. need to do that as well. Sorry. Value and M. Okay. Yeah. So that has to go a bit higher. Initialization. And then we have a new loop. While something, do all of this. But let's start with the while. So when do I not want to go to the top? I do not want to go to the top when we already did this mask with just a one set here. So what happens if we do that? Well, then S becomes 0, right? No, what was S? I just shifted it 1 here. So if S becomes 0, then I want to stop. I don't want to do an exclusive OR. Well, or you could say I shifted 0, that doesn't do anything, and then exclusive OR, then M becomes 0. Might as well test for that, maybe. So while M. That then put all the bits on top of the last bit. So now I can do an AND, I guess, with a Boolean mask. And I want this nonsense. Wait, yeah, if it is all zeros, I want a 1. So I need to invert it. And then do an AND with the Boolean mask. Maybe I should do that immediately. Otherwise, that would be an extra loop again. Sorry, Sam. Yeah, no, I didn't. I just started today, so. As soon as I have this function working, I'll test it, and then it will become clear what it does, I think. Yeah, I need another mask. So we need a mask that is just a 1 for every value. That's basically a Boolean mask. But it kind of depends on bits. So how do we do that? Gonna ask ChatGPT, I think. Again. Well, that seems to work. It's a bit short though. We're doing the same thing here. End to end, understand. Or what was it? Am I wrong here? 1, 2, 3, 4, 5, 6, 7, 8. It's good actually. Or not. Yeah, this is good. This is a bit short, but there's 3 zeros missing again. So that's like 1, 2, 3, 4, 5, 6, 7, 8 bytes. Yeah, okay. I guess it works. Copy. Well, let's not make this an English sentence. No dot. It shouldn't happen that often anyway. Which is the desired result. Yeah, if it compiles, it works. It does not compile. Bits was not declared. You name bits equals vector. Well, vector is derived from what the fuck? Vector is derived from vector template where it defines bits. Does not define bits. Oh, it does not define bits. Let's define bits. Const expression int bits is b. There we go. Still bits is not declared. Why? Oh, all the way up there. Yeah. That was equals. Now we need one more function. And then we can finally play with minesweeper. And that function is called explode. So we go to vector again. Now we add explode. Explode returns a vector. And explode does the following thing. Oh, wait a minute. Explode takes explode is a boolean operation on a boolean vector. So I should not put it there, and nor put it here. Bool vector. Nope. It's called bool vector. Right, what does this thing do? Well, that explodes a bool vector, like literally, like if it is a mine, then 1 is added to all the neighbors. Vector result. Turn result. Yeah, so I want to add something to vector result, which of course has to be all zeros to start with. Let's see, my default constructor uses that, which is just all zeros data. I need a shift, right? I didn't implement the shift yet. But I think I only need, this is like the last function, so I don't think I need to implement the shift. I can just implement it in here. Nah, let's implement the shift and then use it. Basically, we want to do results at current object shifted. I'm just going to do shifted. Current object shifted. Not just this. Shift bits. Okay, the shift is so that should be the bits that correspond to the elements, the 8 elements around the current thing. Because if we shift bits to the left and the right, you just have the element on the left and on the right, right? And if we do calls, then that's above and below. And then left and right of that one. So that gives us 8 elements. So we're taking this object, which is a bool vector, so this is a value 1. We shift it to one of the 8 positions, and then we add it there. And that then is the result. I think this is already done. It's like done, except that I don't have the shift. So you still have to implement the shifts. And that shift is definitely a part of vector, I guess. Could as well be. Operators. Loads and loads of operators, but where's my shift? Note how this must be const. So we're going to shift it a positive value. But it must be a const thing. So again we have a result. Return results. And I'm going to have a loop. And then result.data I becomes, well, shifting it this way. Could give an overflow. So we should start. We should start it at I0, yeah. So data I. Yeah, begin at data 0, and that is just data 0 shifted with the needed shift. However, that could give an overflow. So the overflow is equal to that same data on shifted 64 minus shift the other way. Note that we never shift 0, so no warnings here. And then the next loop, we have to add the overflow to it. So let's define an int64 type overflow, start with 0. And this must become that, or with the overflow. And we don't want to end with an overflow because then we lost some bytes. So I'm going to add an assert here that overflow ends with nothing. Pretty sure that's correct. So again, but now we're shifting the other way. And then we just have to start at data size -1. I being larger or equal to 0. Minus I. Something is wrong here. Something is wrong. What is wrong here? Why am I thinking that this is wrong? Oh shit. This is more difficult than this. It is more difficult than this. This only works for shifts up till 63 bits. Man, I don't want to reinvent the wheel. Surely someone wrote already something that allows me to do this. Or we have an array of words of 64 bits and we want to shift an arbitrary amount. Or do I want to shift an arbitrary amount? The point is I want to shift a lot. Yeah, bits times calls. Really? Actually, bits times calls times... Yeah, before I was saying that we had only one uint64, but this is bullshit. We have bits times uint64. And then we are only talking about a grid of 8 by 8. I'm going to use maybe a larger grid, so we definitely have an array of multiple. So these loops are definitely looping. And let's say bits is 4 still, or even let's make it big. Bits is 8. Calls is, I don't know, let's make it 16. Ridiculous, but okay. Then we shift 17 times 8 is 136 bits, which is way more than 64. So that's not working. How can I make that work? It's probably a well-known problem. So I'm asked, what is the respective context for defining overflow? Are these variables part of a parsing tree? No. I just have an array. Data is an array of 64 bits. An array, 64 bits, and n of them. Overflow here is if I shift 5 bits to the left, if you shift index number 0, so just one of these elements in the array, 5 to the left, then 5 bits fall off and they should go into index number 1. You get what I mean? So let's say I have an array with just 8. So this is my array, index 0 at the bottom, and I want to shift everything to the left. This thing represents this. So I want to shift this 5 to the left, then we get that. Yep. When I begin with this one and I shift this 5 to the left, I get yep, so the top 5 bits here, they are just gone, they are lost. That's what I call overflow. The overflow is what you lost. So I shift this to the left, but I also shift it to the right. And then 8 minus 3 is 5 bits. So then we get this. Maybe I should give them numbers here. 2, 3, 4, 5, 6, 7, 8. Yep, so then the 6, 7, 8, they come here. Now these are the array elements. And the 1, 2, 3, 4, 5 go there. So I call this the overflow. We get the overflow because we just lose that if we shift left. So we shift also right, and then that is the overflow. And then the B's are shifted left 5. So we get just BB 0, 0, 0, 0, and then do an OR with that one, and then you get this. That's how we shift. But if the shift is larger than 64 bits, it still doesn't work. So I have to fix that. Let's, I mean, ChatGPT can't code, but I'm stupid, so I just ask ChatGPT, and then I fix the bugs. I'm still pretty good at fixing bugs, I think, so I'm just giving this as an example, and then I say, please fix it, and then it does something that I can't come up with because I'm too old. I wrote this to shift an array of int 64 types that represent a bit set stored in words of 64 bits. However, this doesn't work when shift larger than 63 or 64, I don't know. In that case, it needs to also use an offset for the index into the array. I think this is pretty common code. Can you reproduce something that works? That's funny, you know. It realized that result has to start with all zeros, so it just came up with this, which is bullshit. But the idea is funny. Yeah, everything must be zero. Well, it is already. And now we get an offset, which is just shift divided by 64. Yeah, yeah. And then the bit shift, then of course that. And then run over that. If I plus offset, so that's just this index, is less than size, then we can do this. It becomes an OR with data shifted to that. Where's my overflow? Just kicked out the overflow. Maybe doing the overflow here. That is overflow. This goes where? Yeah, that's overflow. So that is +1. That's correct. I plus offset +1. Bit shift is unequal 0 because then yeah. And that is less than size. Well, pretty cool. Pretty cool. I don't think there's a bug in it. Let's copy this. Actually, let's copy everything. If this is false, I plus offset is not less than size, data size. Then if we add 1 to it, it's certainly not less. So this is false and this is also false. So we don't do anything at all then. Therefore I might as well test that I is less than size minus offset. In which case this is always true. Still like my overflow better. Do it in a separate loop. Since I'm not changing data, let's do it in a separate loop. So we do this again. Now we only do that if bit shift is unequal 0. Which means that this is always true. And then to make sure that that is true, I might as well subtract 1 here as well. And this is always true. Okay, now I should. Okay. And then this one again. I'm really lazy. Plus I should go to bed by now. It's bedtime. It's kind of impressive. Sometimes I'm amazed by what this thing can do. totally insist on different indentation, but for the rest, we did get rid of the braces. Yeah, I guess it is just correct. I mean, I couldn't think of it myself because I'm just stupid and stuff, but we start here at 0, so here we start at data size -1. Super logical. And then here we have I plus offset, so here we have I minus offset. Feels logical as well. Shift the other way, shift the other way. That remains the same. Now the +1 becomes a -1. And you have to make sure that I must be larger than offset, because otherwise this is negative. So it could be offset +1, but that's the smallest value, and then it becomes 0. Yep. And here just same thing, but then for offset. Looks correct to me. No match for operands plus equals. Oh, I did not implement plus equals. That would be the last one, I think. Sam, what are you talking about? Did you place any document? No, that was pretty good. Okay, and so that one. So is this leading padding by the masking algorithm? I don't understand. Will there be a meta locator for the user interface? Cursor on screen. What? User interface? Nah, I never do user interface. Result is a vector. I have to implement one more little thing. I do have an operator minus. That should be easy then. Change this one. Aha. Okay, nothing crashes. Now we are going to explode these mines. So that means that this one is going to be added to that field, 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 and that field. Yes, all 8 around it. And this one is going to be added to those 8. And this one is going to be added to those 1. Yeah? So you expect in that case to get a 3 here. Because this one is being added to that, and this one is being added to it, and this one is being added to that. And the way I did that is by shifting this, well, bit set, more or less. Calls. So the number of calls is 1, 2, 3, 4, 5, 6, 7. The number of bits we see now is, well, 1, because it's just only once here. So you shift this whole thing, 7 plus 1 is 8. Then you get the 3 ones. They come there. Yes. Which means that this one is being added to that, this one is added to that, and this one is added to that. All in one go, single add. And then I shift the whole thing, and all the other ones as well. Right? All of them go to the top left and they are added. And then we shifted 7, so then these 3 come there. So now this one is added there, this one is added there, and this one is added there. And then we shift into there, so this one is added there, this one is added there, and this one is added there. And then we have 1, 2, 3, 2, 1, and the rest is also already filled. So in total we do 8 shifts, we add them, and then the whole thing is exploded. And I want to see that work before I go to bed. So I think I just need to do solver, get my mines again in a vector. Vector mines is a grid mines. And then bool, no wait a minute, mines is a bool vector. Bool vector. And then I can call, I can do vector borders. Mines explode. Standard cout. Borders. And lo and behold, it worked. I'm good. I did not make any error. I mean, ChatGPT did not make any error. So, you know, this Boolean vector is exploded into this vector. And what does it mean? This means that there's no mines adjacent this square. 0. No mines here. Here there is one mine neighboring it, and we see that back here, 1. Well, for example, this square here is bordering on 1, 2, 3, 4 mines. So, yep, 4. This one is 3, so that's that 3. Now, what is the largest one? Here we have a 5, for example. So that is this one. 1, 2, 3, 4, 5. So it works. And I guess I go to bed. One viewer left. Now the fun really begins, because well, the first hours I worked on the build system and printing this. This stream I worked on, well, all the operators, so we can actually do stuff like this. And then tomorrow I'll finish it and we'll finish the solver. Because with the operators that I have now, I can figure out where a mine is and where certainly no mine is. Just with a few, it's actually so easy that I might as well do it right away. Nah, it's too late. I'll do it tomorrow. So, thank you for keeping me company, and I'll be back tomorrow.